So the FRED2 project has many ambitious goals. Basically, FRED2 is about bringing together experts on the fields and academics so that they can share knowledge and expertise in order to come up with a map of concepts, essentially, that can help in detecting and predicting behavior and risk profiles. And so the general idea is to protect the financial interest of the EU countries. And today I am here because I would like to present this map of concepts that was possible to be elaborated thanks to all the meetings and the discussions that we went through during the past, I would say, 1.5 years, more or less. So we tried to do a little bit more, at least trying to find a way in order to move the first steps toward a decision support system. So a decision support system is basically an information system that gathers informations and supports decision-making processes. A decision support system is relies on, say, two main legs. On one side, the idea is to gather useful information, and that's the first leg. And the second leg is based on smart analysis of the relevant information. And if one leg is missing or is limping, then the decision making will fail. So, for example, when we say information, we have to add useful information, because a lot of information does not mean useful information. We could easily draw into data nowadays. We have the internet, so it's very easy to have access to data. So we need to carefully decide what relevant and useful information is. And another way in which a decision support system could limp and could fail is on the side of the other leg, meaning the side of the analysis, in the sense that, for example, if we would implement a built-in, rigid and unchangeable system of data analysis, well, that's not something that we would like to do. Again, because we live in the era of the internet, all the researchers are interconnected. We have plenty of open source, very powerful softwares. And of course, I have in mind Python and R to begin with. And so there is a huge scientific community that is every day contributing in developing powerful algorithms. We always have to remember that fraudsters are smart. They have a strong incentive in succeeding in their work. And the reason is that if they succeed, well, they have a high reward. Okay, so let's see in a nutshell this the first steps toward this decision support system. We can ideally imagine that we have 4 steps. In the first step, what we have to do is to decide the so-called unit of analysis and carefully planning the useful information that we want to gather. And this information could be either structured and unstructured. We will see later on each of its steps in a little bit more detail. In the second step, what we have to do is to plan, again, very, very carefully, the so-called key frauds indicators. And then what we have to do is to make some data pre-treatment. in the third step, um, is the moment for the data to be analyzed. And we can do that essentially using either a supervised or an unsupervised algorithms, or both, of course. And then at the fourth step, we have the output. And this output must be validated. And it could be validated, for example, with law enforcement or directly on the field. And it is quite possible that after the validation, we need to go back to step 3, analyze the data again, and come up with another output, hopefully improved. Okay, step 1, unit of analysis and useful information. The first thing to do always is to decide what is the unit of analysis. Meaning the element we are interested in and about which we would like to draw a conclusion. So, for example, in our context, we could decide that our unit of analysis could be a project or a funded project, or, for example, a firm that received funding for that project. So this is important because all the information that we gather must be measured directly, or it should be possible to link the measure to the unit of analysis. So, for example, if we decide that our unit of analysis is a funded project, then we can gather some structural information, like, for example, the amount which was funded. And since generally each project is presented by a firm, then we could also add information at the firm levels. And so, for example, gather, I don't know, the revenues or measures of performance of the firms and so forth. Also, what we could do, but we really have to think carefully if it's worth it, is add unstructured data like text or data that could be gathered from social media, pictures, and so forth. Always keeping in mind that unstructured data need a lot of pre-processing work to make it usable. The second step, that would be the key indicators of fraud, is a crucial step, because the idea is that we want to transform all the information that we gathered into what we call in statistics informative variables. That is quantities that can give a lead toward the identification of a fraud. And this quantity can be used for statistical analysis, of course. This process requires the co-working of statisticians or data scientists and expert on the field. The third step is the step of the data analysis, and depending on the structure of our data, we can use supervised algorithms or unsupervised algorithms. And basically the difference is that relies on the fact that we could know the status of our unit of analysis, and we could know if that unit of analysis is fraudulent or not. In this situation, we could use algorithms that goes under the umbrella name of supervised algorithms. If that status is not known, then we have to use unsupervised algorithms. So one could argue, well, but if I know the status fraudulent or not fraudulent, then what is the point of using algorithms? Well, actually, the point is that you could use that information on past data and see if there is a pattern in the data that could help you predict if new projects are fraudulent or not. That is the general idea. Then the fourth and last step is the output. Well, basically, the output is a measure, so a number that is attached to each and every units in our analysis. And this number gives us evidence of the risk of fraud. So, for example, if we have decided to analyze firms, then we would come up with a measure associated to each firm, and the higher that measure, the more likely that firm is fraudulent. We always have to remember that this is a statistical estimation, and we have to validate uh, the process. Okay, in the last part of my presentation, what I'd like to do is to show you an application of this map of concepts. And this application was based on on a sample of Italian building and construction companies. And so we will go through all the steps of the analysis. In the first step, we had to decide the unit of analysis. Well, in this case, since the information at hand somehow imposed us to choose the firm as unit of analysis. Then we planned the relevant information, and we retrieved that relevant information from balance sheets and financial statements of the firms. In the second step, we decided the key indicators of fraud. This was a process that took us a lot of time, and the work group of Sapienza and other colleagues defined a set of indicators, and we built that set of indicators using the balance sheets and financial statements. And an interesting fact is that we were able to validate this key indicators of fraud thanks to the work of our partner Fondazione Nazionale Commercialisti, and later on we will have a presentation of the results of this validation process. If you would like to have more information on the key indicators of frauds, you can take a look at the webinar that we had on the 27th of June of this year, and it is available in on the Fred 2 website. Then, in the third step, that is the step of the data analysis, what we've done is that we used unsupervised algorithms. Actually, this was the only opportunity that we had due to the data at hand. And we used algorithms of anomaly detection, and we used the Bamford law. And in the fourth step, what we had was an output, and this output is the list of our firms, but these firms were ranked from the most suspicious to the less one. Unfortunately, we were not able to validate our outputs so far. Okay, so here is our case study. We built a data matrix on a sample of 600 building and construction companies operating in Italy and active during the 3 years at least 2017, 2018, and 2019. Here, the idea was to analyze a set of firms before the COVID-19 pandemic, just to have a sort of normal period. And we retrieved the information using the AIDA database that is available for the Sapienza professors and students. We built 37 key fraud indicators. Again, if you would like to have further details, go to the Fred2 website and look at the webinar we held on the 27th of June. Okay, so then we fed this information to some anomaly detection algorithms. And the key idea here is that firms that tend to be fraudulent are different from the others. And since we have some key indicators of frauds, then the algorithms would identify and highlight, hopefully, of course, the firms that behave differently with respect to all these key indicators of frauds altogether. We run 6 anomaly detection algorithms. Those are just some of the algorithms available in the literature. And each of the algorithm provided with a score. And the interpretation is that the higher the score, the greater is the company anomaly. Again, if you look at the webinar that we had on the 27th of June, you can have a complete overview of the statistical techniques that can capture anomalies. Then what we had to do was to, select the best anomaly detection algorithms. And the selection was based on the capability of each algorithm to discriminate between, say, normal firms and anomalous one. And in order for an algorithm to discriminate, the general idea is that the majority of the firms should receive a low score, meaning that the bulk of the data is not anomalous, and just few firms should receive a high score, meaning that those firms are different from the others, so anomalous. And we repeat this exercise for each of the 6 algorithms, and we were able to discard the last 2 because they did not discriminate at all. Then we compare the answers provided by each of the 4 algorithms retained, and the answers, meaning the score. The answers were consistent, and I say that because the correlation between the scores of each pairs of algorithms is always positive, might be higher or lower, but the score is the correlation, sorry, is positive. Then we were able to plot our data, and so we took each pair of scores, and basically we plot the data. And as you can see, for example, in this graph on the left, I have several points. Each point represents a single firm, and as you can see, the firm is labeled Then, of course, you can label the firm using, I don't know, the name of the firm, or the partita IVA, and so forth. Of course, for privacy reason, I've hidden the name of the firm and just assign a label that means, I mean, nothing, in the sense that it's simple. It's a simple number. And so, as we can see from this graph on the left, we have the bulk of data, which is close together, with the low value of the scores. And this means that we have a huge amount of firms which are, say, normal. And then we have just a few points which tend to be detached from the others. So these are the anomalous firms. And as you can see, the interesting thing, although not surprising, is that if we compare the results coming from the graph on the right and the graph on the left, then we have basically the same answers. So, for example, this firm 207 seems to be very, very different from the others, just like the 174 and the 22 and so forth. Okay. So at this point, we were able to assign to each firm a score of anomaly. Then we decided to refine the analysis using the so-called Bamford's law. So this law describes the frequency distribution of leading digits of number in a data set. So, for example, imagine that we have our sample of building and construction companies, and we decide to observe their revenues. So imagine we have a value of the revenues for each firm, and that's a number. If we take the first number, then we have the so-called leading digit of this set of data. Well, it is well known and established that in many situations, and there were huge applications of the Bamford law in accounting systems. The Bamford law tells us that if there is nothing weird going on in our data, then the distribution of the leading digits is known, and it's this one, the one displayed in the graph. So the idea is that the most common first digit that we have is the number 1, because this would occur almost approximately one third of the time. Then the number 2 is the second most common, and so forth. So, for example, if in our data we have plenty of 9, then there is something weird, at least with respect to the Bamford law going on, and maybe it's the case to take a closer look. So what we did was to use the anomaly detection algorithm with the Bamford law together. How? Well, what we did was to construct some indices of conformability to the Bamford law. We used this one, the MAD, which is, just one index, but is widely used and quite reliable. And so what we did, remember, we, thanks to the anomaly detection algorithm, we were able to rank our firms from the most anomalous to the less anomalous. Then what we done was to extract the first digit from the revenues of the sample of firms, and we were able to check the conformity of the overall sample, the conformity to Banford law, using the overall sample. And we have a number, we get a number. And we are going to call this number MAD 600, meaning that it's a measure of conformity using all the initial informations, all the initial firms, the whole sample. Then what we did was to exclude the most anomalous firm. So now what we have is a subsample of 599 firms, and we computed the MAD for this subsample. And we come up with a measure of conformity that we called MAD 599. Then we excluded the two most anomalous firm and computed the MAD. And we get another number that we called MAD 598. And as you can see, we could repeat this process, excluding the third most anomalous firms, and then the fourth most anomalous firms, and so forth. So we repeat these exercises, the step 4 and 5, over and over again until we exclude the first 200 most anomalous firms. Now, here is this nice result that we obtained. So this graph shows us, we have to look at the blue line, and we have the value of the MAD, meaning the conformity index, for the entire sample is this point. And then we have the value of the MAD for the subsample of 599 firms, and so forth. And as you can see, this is the nice results that we obtained. As we remove anomalous firms, then the MAD tend to decrease. And this means that since the higher the MAD, the most non-conformable to Banford law is the sample of firms, then that means that when we remove anomalous firms, then we tend to have a sample of more conformable firms. Okay, so is this enough to say that the anomalous firm are fraudulent? Well, no, not necessarily, but and this is the decision support system. The idea is that these tools can provide a way of identifying firms that could be worth looking at. Of course, we should validate the algorithm, meaning test if it really works on the field. Okay, thank you very much.